Right, let's start talking about the breaking point first. That's the easiest one. Breaking point is when we're looking at a stress strain graph, is identified as our last point on the graph, and regardless whether it's for a ductile material or it's for a brittle material. Um, the last point in the graph, and if you don't have any more strain beyond that point, then that means that that point is known as the breaking point or breaking stress. Okay, so that would be the last point. That's the easiest one to discuss, the one from the question that you've asked. Now, the next point is the ultimate tensile stress. So the ultimate tensile stress is the maximum stress that the material can handle. So regardless of what stress strain graph you see, find the highest stress that you can see on that graph. Now you can see that the highest stress is at that point there. Okay, so that is not the breaking stress, okay, which is here, but actually it's there. Now, the uh, remember, this comes first, then the material would break. Okay, so once the material undergoes an increase in stress, and let's say we get to this much stress, okay, you will get molecular permanent changes and particle permanent changes in position within that material. That could, from that point on, weaken the material, which is what happens. The material gets weaker, and that's why less stress is required beyond this point to stretch that material, to strain that material and extend it, because you've permanently changed something within the material that's made it weaker. It doesn't need the same amount of stress anymore, and it will continue to extend. Okay, so how would you know that? Experimentally, there are techniques to figure these things out, but why the dip is there is because there's a structural change when a significant structural change within the material that beyond this point no longer requires the same amount of stress as before to increase the extension. So this point comes after you reach that. Okay, now that is the ultimate tensile stress. For a brittle material, let's say you've got brittle material, and let's say there we go. Now, E and F, so if you want to talk about it, that point there is E, is the ultimate tensile stress because it's highest possible stress. But when it gets to the ultimate tensile stress, it also breaks. So that's F as well. So it's not just E for brittle material. Okay, so if you want to identify on a graph, it's quite easy. You just pick the highest point on the stress, and that's what you get. Now, why there's a dip on a stress strain graph is because there are permanent changes within the material once you start putting excess load on it, and because the material has molecularly changed and the particle level, then less stress is needed to extend it beyond that point. Okay, now yield point. What is the yield point? So here on this we've got a couple of yield points. What does that mean? Well, definition is there's a large extension or there's a large strain for a small stress. So suddenly the amount of stress that you put in before, so if you look at the amount of stress that we put in before, let's say we put this much stress, there wasn't much increase in strain, in extension. But when you go beyond a certain point, so you get to a certain point, Let's say C is the upper yield point. So what happens beyond that? You no longer require the same amount of stress to extend that material. So that's why we say, you don't need much more stress beyond that point, and it'll continue to extend. But the lower yield point is if you continue to, so don't worry about upper and lower yield point. What you're trying to look for your syllabus is a flatter region after the steep region. So after the steep region, you're looking for a flatter region, and the yield point is the beginning of the flatter region. Okay, so D, beyond D, the material yields. So less stress is required compared to before, compared to here, to have a large strain. So here, look how much stress was required to have this much strain. Now, you don't need as much stress increase to get the same amount of strain. Okay, so what does the yield point actually mean? It means that less stress is required and a large amount of extension is seen and observed beyond that point. Okay, so not much stress for a large amount of strain. Okay, a large amount of extension. So that's the yield point. So beyond that, the material yields. Okay, it gives way a little more compared to the amount of stress that you had before. So how do you define it? Now this is a bit of a bumpy stress strain graph. Now the drop here corresponds to when the material undergoes this process called necking. So just before it breaks, it kind of it gets thinner in one region. It doesn't break, and then if you carry on putting stress on, is then this region that extends. Okay, and then it'll break somewhere down here at some later point. Okay, so that whenever you see a dip, that's called necking. But a yield point, if you want to look at it, often you'll see graphs like this, easier ones. Let me get that right. To interpret, and let's say that there looks something like that, and then starts to curve like that. So you would say that your yield point would be where, as you could see that. So where it starts to flatten off, you would say your yield point roughly around here. So not much stress is required, but you get large values of strain when we increase the stress by a small amount. Okay, so that's your yield point for that particular material.